Hey guys, part 10. This is going to be called First Revolve. We're going to add a new feature to our tool belt, and that's the Revolve tool. We did this before in basic parts, but that was kind of just showing you how to make basic shapes. That was just kind of showing you how to make the basic shapes. So I think we did it specifically within the torus tool, or the torus part, which is like a donut or an O-ring, applicable in a lot of places. But what I want to really talk about with this one is revolved features around an axis that aren't symmetrical. And so when we say this, we could think about if you wanted just this piece, this like two, you could just draw a circle and extrude it. We don't need to revolve it, right? We could just circle and extrude. We technically could draw a larger circle, extrude it, and then another circle and extrude it off of that plane. You could draw it that way. But there is a easier way to draw this entire shape pretty simply, and then only make one extrude cut for this little notch here. So I'm going to show you how to do that. Let's pop in there and do it. And you'll notice we didn't use global variables this time around, mainly because we just don't really need them. We could have done the global variables for the radiuses, but I didn't see a point, so I figured we'd keep it simple with this one. So let's talk about this. Let's talk about this. Let's exit out of this actually. Think about this from the side view, right? Think about this from the side view. Could be a little tough for some people to imagine, so maybe let's grab the side view. Ooh, this doesn't like that. Let's model project, first revolve. Let's bring in that side view. Could you imagine this profile cut in half? You basically just have this kind of shape, this long L shape. And if you imagine it where it's cut in half at that axis and you revolve it around a circle, it's like 360 degrees. It would create this shape. So let's do that real fast. Let's try that. See what we get. Oh, not that. Not that. Sorry, guys. Oh, not that. Oh, geez. Okay. A little fun there. Okay. We're in our part. Jeez, I just can't click for crap right now, can I? We're in our part. We're on... ISO is like this, right? We could see our part coming into here. So if we sketch on the front plane, we're going to get that side profile that we imagined earlier. So let's imagine that. Let's do this. Let's do this. Let's do this. This. And there's that axis I talked about. Now we have the general shape that we're going to revolve around that axis to create the part. Let's see what dimensions we can get from this. We know this is a radius of 25. So radius actually works good for here because we don't need to cut anything in half because we're already cutting the circle in half. So let's look at this. 50 and 25, that's easy. We have a distance of 25 and distance of 75. Let's bust that out. We said 50. We said 25. We said... I think it was 25 and 75. Let's do it how it's drawn. Not 7. Cool. We have our part fully defined, or our sketch fully defined. Let's use our not extrude boss revolved. And you can tell it just wants that axis of revolution. So let's pick it. Like magic. Let's look at that ISO. Now what we're missing is that top cut, correct? Yep. So let's look about what they want here. It looks to be a notch from a rectangle that's 40 millimeters from the bottom, and it's most likely tangent to the circle if they didn't give that height of those arms there, because those arms could change dependent upon this if it's tangent to the circle. So let's add that in and see if it makes sense and works. Let's rotate, sketch. Let's put a little rectangle in here. We know it's we don't know the height, so let's just enter that. But we know it's 20 wide. We said the top of it was most likely tangent to the circle. Awesome. We know the distance down here was 40. Oh, because we already have this. And let's erase that. We don't need that distance. We need this distance. Is it 40? Cool. We already know that distance is 20, but we want the distance here. It looked mid-plane, but let's double check and see if they gave us that. No, but it's pretty clearly centered to the part. So we have our box with our 40. Let's see what this length was now. Oh, 10. So it's a good round number, which makes sense. And the beauty of this type of change here is if you made this like 35, that notch gets deeper, but you still have the correct tangency and profile of the cutout. So let's do that, and then let's make our extruded cut. We already know how to do this. This is easy. Up to next is done. Let's make our ISO view. Cool. Quick, easy part. Honestly, these kind of parts are very they're very quick and easy to see if you know what you're doing. But again, let's do this just to see how long it would take. So we're already at 5 minutes. We could probably get that in if I do it quick. For this other way, we'd be sketching on the right plane. We'd make a circle that was 50. Oh, I did not. I skipped a step. Let's back off. Tonight. It'd have to be right plane. We have our thing right. Let's say 50. Yep. Or was it 100? It'd be 100 because it's a radius of 50. Yeah. So see, things get a little bit weirder when you start working in different measurements like that, or different styles. So let's do that, and I will extrude it. Yeah, forward, not mid plane, 25. Cool. And then we could always sketch on this front plane, draw another circle, and I think that one would have been 50 because it's 25 radius. And then we could extrude this off 75. Yep. And then we could sketch the back and make our box and do all that. And it comes out the same. Excuse me. But as you can tell, the other one just kind of, it's an alternate way of doing it in a way that if you have a much more complicated side profile, like there's very complicated side profiles. You can get like rotor discs and stuff like that for cars that are sloped at a single edge. And honestly, let's just back off and I'll throw in a really complicated one right here real fast in like 2 minutes, and then we'll see where and how complicated it can get. Sketch front plane. I think I got the right plane, but it's okay. Let's actually back out. I don't want to mess anyone up with that. Let's do front plane. So let's imagine this. Let's say we had some like weird rotor part that we needed to design. Let's come out 10. Let's come down at a slope of like 10. Let's make this kind of like an interesting angle of 30. We'll throw another one in here that's coming down at 20. And this will be an angle from this of 50. Cool. And we have like this piece coming down, and maybe like another little thing here. Who knows? Oop, not that. This needs to be coincidented. And we could dimension this. Sorry, I know I'm going fast, but we're just kind of showing you a little bit of an example here, right? This should dimension the rest of it. No, it doesn't, because we don't have these. Okay, that should dimension the rest of it. Yep. Let's finish that sketch in with this part. This one line. That seemed like it went over, oddly enough. Let's try that one more time. Interesting. Okay, we have that there. We can revolve, and that was a quick 2 minutes. And now kind of look how much more interesting these pieces can get. And now let's think back to our last example where we extruded a couple times to get out to that point. Would you want to do one disc extrusion of 10, a draft extrusion at 30 degrees of however distance, another draft extrusion at 50 degrees, and then another extrusion at 10 with no draft? So yeah, you see how quickly these things can get complicated, and you don't want to over simplify things by making just some cylinders that extrude, because you will get these kind of things on a test, and you'll get ones that are cut in at the center too, and you need to make them very defined, and it gets complicated quick. So let's be thinking about those differences in our parts and how we can use them. As always, best practices, guys. Drawing first, give it a try, see if you can bust it out. If not, watch the video. This one you might need some tricks of the trade. You might do it wrong, you might do it, not wrong, but you might do it the way we talked about with the double extrusion when we need to revolve. All right, I think that's it for this one, guys. Appreciate it. We'll leave the mass properties in the description. If you have any questions, comments, just leave them. Let me know. Thanks, guys. Appreciate it.